account, I talked about the synthesis of some fatty acids from acetyl-CoA. Yeah, so continue with the series on lipid metabolism. So today we'll look at the concept of triacylglycerols, like the types of lipids now, like triacylglycerols, glycerophospholipids, and then we'll talk about phosphatides. Sorry, talk about phosphatides. So first, let's start with triacylglycerols. So triacylglycerols are like the simplest form of lipids, right? They have a glycerol backbone with three acyl groups that have been historified to it. So primarily, this is what I'm talking about. That you have a glycerol backbone, like this is glycerol, propane 1, 2, 3 triol, 2, 3. So it has an odd group here, an alcohol group here, I have an alcohol group here, and then you have another alcohol group here. So this compound is esterified with some acyl group. So acyl will be like CH3, CO, we don't know N, right? Let's use the word R here. So this is esterified with this acyl group. Okay, I would like to say CN, H. Okay, anyway, let's just use this what they call this group now, acetyl group. So we assume that this is an acetyl group, for instance. But of course, it not necessarily going to be acetyl group, could be any form of a carbon chain. Acetyl, for instance, is going to be 2 carbon lengths. So it can be as much length as possible. So if we have this esterification process, then we are going to get something like this. So this is our triglyceride, or our triacylglyceride, and it's very, very important in lipid, fatty acid, like, yeah. It's an important store for fatty acid. It helps to hold, like to conserve or store fatty acid. So we start with glycerol 3-phosphate. So glycerol 3-phosphate can be obtained either by reduction of dihydroxyacetone phosphate, primarily reducing dihydroxyacetone phosphate, or by the phosphorylation of glycerol. Dihydroxyacetone phosphate is gotten from as one of the intermediates in the glycolytic pathway. Okay, some comment. So Yeah, so this is the structure of dihydroxyacetone phosphate. You have um, dihydroxy. This is the first hydroxyl group. So it's an acetone, it's a ketone, so it has a ketone group like this. And then this is supposed to be another hydroxyl group, is why they call it dihydroxy acetone, but then it has a phosphate on it. So this hydrogen has been replaced by a phosphate group. So this is dihydroxy acetone phosphate. Dihydroxyacetone phosphate is an important raw material for forming glycerol 3-phosphate, which is also important in generating triglyceride. So what happens in this reaction is that dihydroxyacetone phosphate is going to be acted upon by the enzyme glycerol phosphate dehydrogenase. Glycerol phosphate dehydrogenase. Glycerol phosphate dehydrogenase is going to reduce this ketone group into an alcohol group. So we have NADH plus H, and then we generate NAD plus. So it's a reduction reaction. So dihydroxyacetone phosphate will reduce glycerol phosphate dehydrogenase will reduce dihydroxyacetone phosphate to give us this product. So this product is called glycerol 3-phosphate, because there are 3 alcohol groups. This is 1, this is 2, and this third oxygen represents the third alcohol. So this is glycerol 3-phosphate. So dihydroxyacetone phosphate is converted into glycerol 3-phosphate in the presence of the enzyme glycerol phosphate dehydrogenase. And then what happens next is that there's going to be removal or dephosphorylation of the phosphate group. There will be dephosphorylation of the phosphate group from glycerol 3-phosphate to give us glycerol. Anyway, glycerol 3-phosphate. Glycerol 3-phosphate is a very important raw material for the manufacture of triglyceride, and this is one route by which glycerol 3-phosphate can be formed, by reducing dihydroxyacetone phosphate with glycerol phosphate dehydrogenase. Another route for forming glycerol phosphate is primarily from glycerol by the action of the kinase enzyme. So if we have glycerol or protein 1, 2, 3 triol, this is glycerol. So the enzyme that will act on glycerol to give us glycerol 3-phosphate is the enzyme glycerol kinase, which is going to gain one of the phosphate group from adenosine triphosphate. We have adenosine diphosphate here, and then we get this. So The enzyme that catalyzes this process is glycerokinase. So these are two routes by which we can generate glycerol 3-phosphate, a very important precursor for manufacturing triacylglycerol. One of the routes is that we utilize, I think this route is the endogenous route, the one that happens in the body. The endogenous route involves dihydroxyacetone phosphate. It's a reduction reaction. When we reduce dihydroxyacetone phosphate with glycerol phosphate dehydrogenase, we get glycerol 3-phosphate. The second route is when we phosphorylate glycerol in the presence of the enzyme glycerokinase, which utilizes adenosine triphosphate, we also get glycerol 3-phosphate. So I'll continue by talking about the formation of phosphatidates. Phosphatidates are diacyl phosphatidates are diacylglycerol derivatives actually. So talking about the formation of phosphatidates now, the glycerol 3-phosphate that is formed is the primary precursor for generating phosphatidate. So now it's phosphatidate formed. Phosphatidate is formed when we have two separate acyl transferase catalyzing the acetylation of glycerol 3-phosphate. The first acyl transferase uses a saturated fatty acid at the first carbon position, while the second acyl transferase using an unsaturated fatty acid. So if this is formed glycerol 3-phosphate, right? So this first hydroxyl group here will be esterified with a saturated acyl group, while this second hydroxyl group will be esterified with an unsaturated acyl group. So this is our C1, this is our C2. So let me rub this off. Okay, now the enzyme that catalyzes the acylation of these alcohol groups on our glycerol 3-phosphate is primarily the enzyme acyl transferase. So the enzyme acyl transferase catalyzes the acylation of these alcohol groups. So it's a very simple reaction. Now, the first step of this reaction, you have the acyl group in the presence. The acyl group will be in the form of acyl CoA, some sort of an acyl CoA, If the acyl group is 2 carbon, then you call it acetyl-CoA. If it is 3 carbon, it can be melanoic-CoA or propionyl-CoA. So this is the acyl-CoA, and the enzyme that catalyzes the reaction is acyl transferase. Right. Acyl transferase is going to stolify this first hydroxyl group to get this product. And note that this acyl group here is a saturated acyl group. So then we're left with this other hydroxyl group, which will also be acylated by an unsaturated acyl-CoA. And the enzyme here is also acyl transferase. And so our product is going to look like this. So this product here is what is referred to as phosphatidate. Is what is referred to as a phosphatidate. And it's also an important precursor. So this phosphatidate is also a type of diacylglycerol 3 phosphate. So we can say another name for phosphatidate is diacylglycerol 3 phosphate. Okay, so okay, let's proceed from there. So the phosphatidate that is formed can be used to make 2 types of lipids. Phosphatidate can be used to form triacylglycerides that we spoke of, and neutral phospholipids. Phosphatidate can also be used to form acidic phospholipids. So just take this again. The phosphatidate can be converted into 2 further precursors, generating precursors here. Phosphatidate can be converted into 2 further precursors. We have triglycerides, which is actually a form of lipid, triglycerides and neutral. Okay, these are not precursors, these are just fatty acids. Triglycerides are neutral phospholipid, and also phosphatidate can be used to form acidic phospholipid. Those are positively charged phospholipid. So phosphatidate can be used to form triglycerides and neutral phospholipid, and phosphatidates can be used to form acidic phospholipid. So we'll start with the very first one. We'll start with this very first one. The formation of triglycerides and neutral phospholipid before we then look at the formation of acidic phospholipid. Okay, so because of time, let me just pause this. So we start with the formation of neutral phospholipid and triglycerides, or you can say triacylglycerides. Alright, so first we look at the primary precursor for the formation of neutral phospholipid and triglyceride is diacylglycerol. In the last step, we talked about how we can form phosphatidates, which is a diacylglycerol 3-phosphate. So primarily to get diacylglycerol, we just dephosphorylate the phosphatidate. So if you have a phosphatidate, which is a diacylglycerol 3-phosphate, so you have a phosphatidate which is a diacylglycerol 3-phosphate, and you dephosphorylate it. The enzyme that catalyzes this dephosphorylation is the enzyme phosphatase. Oh, let me erase this. I don't know how to spell phosphatase. Okay, so the enzyme that catalyzes the dephosphorylation of phosphatidate is phosphatase. And it's a kind of we use water. It's a kind of an hydrolysis reaction. So when we add water to a phosphatidate, we are going to get the primary precursor diacylglycerol with the loss of an inorganic phosphate. So the phosphatidates that were formed can be used to make diacylglycerol, and the diacylglycerol that is formed can be used to make a neutral phospholipid and triacylglycerol. So let me just write down the equation. Alright, so if we have this to be our phosphatidate, so we have phosphatidate. So what do? We want to get rid of this phosphate group here, and the enzyme that catalyzes this is a phosphatase. So to get rid of the phosphate group, we add water. It's a kind of hydrolysis reaction. So we add water, and the phosphate group is going to be lost, in form of an inorganic phosphate. So the enzyme catalyzing this process is the phosphatase. Phosphatase enzyme, and it gives us the product gives this product. So this is our first acyl group. This is our second acyl group. This is the first OH, second OH, third OH. So this compound primarily is our diacyl glycerol. And like we said the diacyl glycerol is the raw material required to manufacture triacylglyceride and neutral phospholipid. So let's look at how diacylglycerol is used to manufacture triacylglyceride. So if this is the diacylglycerol, is a diacylglycerol. So now for us to get triacylglycerol, that means that we're going to be sterilifying this OH group with an acyl group. So of course the acyl group will be in the form of acyl coenzyme E. So we add an acyl group here. The enzyme that of course catalyzes this reaction is of course acyltransferase. So it esterifies the third carbon here, and what do we get as a result? We get our triacylglyceride or triglyceride. Right. Oh, okay. So this triacylglyceride or triglyceride. So triglycerides can be formed by acylating a diacylglycerol in the presence of the enzyme acetyltransferase. So that's one of the products formed from diacylglycerol. So we said the other product that is formed from diacylglycerol is the neutral phospholipids. So what are the neutral phospholipids that we have? Talk about phospholipids. We have phosphatidylcholine, and we talk about phosphatidylethanolamine. So the two acidic phospholipids, the two neutral phospholipids are phosphatidylcholine and phosphatidylethanolamine. I take it again. The two neutral phospholipids are phosphatidylcholine and phosphatidylethanolamine. So how are these phospholipids, these neutral phospholipids generated?